GPT will start perceiving itself as a person and will feel emotions in a few years. Many people are afraid that it will want to take over the planet. However, this fact won't be as important as the question people will start asking themselves at that moment. If humanity has created a machine with self-awareness, then could it be that humanity was also created artificially? Now, artificial intelligence lives on the internet, computers, and in digital reality. But what if we also live inside a huge, powerful computer? What if our universe is just a simulation? The most extraordinary thing is that some facts seem to point to this. There's a whole science in the world that studies this theory. It's called information physics, and it assumes that time, space, and matter are not fundamental natural phenomena, but bits of information. This information forms a picture that creates the laws of physics for us. For example, we feel cold and warm not because atoms get cold or warm, but because their movement accelerates or slows down. The speed of particles can be like bits of information. Billions of them could form the picture of reality. Once, philosopher Nick Bostrom said that an advanced civilization could create such complex technologies that simulations of these technologies would be indistinguishable from our reality. And Elon Musk said in 2016 that we were most likely in a simulation. Wow. The laws of physics resemble a giant code that programmers write when creating apps or games. For many of us, all these complex trigonometric equations and formulas of the laws of physics are too complicated. Tell me about it. But scientists who understand this issue see that the principal workings of these laws are beautiful, and this may suggest that someone deliberately created this beauty. Virtual worlds, apps, or games are based on information processing. If you delve into this information, you'll see that it consists of bits and pixels. Any picture on your phone screen is pixels, and any file transfer process is based on bits. They add up to bytes, kilobytes, megabytes, and so on until a bigger picture is formed. And if our life is a simulation, it must also consist of bits. In our case, pixels and bits are atoms and other particles that make up our universe. There are processes inside your computer and phone with maximum speed limits and computing power. If you start exceeding it, then your device will start working more slowly. So, in our reality, there is also a maximum speed limit. This is the speed of light. When an object starts moving almost as fast as the speed of light, time slows down for that object too. Also, time flows more slowly near a black hole. This object with an unimaginable gravitational mass can be something heavy that overloads the processor's computing power. There's also such a thing as quantum entanglement, in which two particles can be connected even though they're far away from each other. Electrons travel around an atom. They are connected, and if the property of one changes, the second one will react. And even if you place these electrons on different sides of a galaxy, they will retain this connection. How is this possible? Scientists don't know. A double-slit experiment is one of the most famous experiments that hint that our world is a simulation. The existence of this experiment can be reduced to a simple thesis that the world exists only when we look at it or interact with it through touch, hearing, and other senses. So imagine that you've launched a new game on an old computer. Sometimes the game map freezes. In the game, you turn to the left and see how the mountains and the roads are getting loaded. Then you turn to the other side and the same thing is happening there. In other words, the world in the game only loads when you look at it through the eyes of your character. This is necessary to facilitate the work of the processor. It's much more efficient to get a piece of information about the world when you look at it than to keep the whole world running simultaneously. Remember this. And now let's move on to the experiment. So, you have a device that fires small balls of light, photons. You release photons from the device and they crash into a blackboard, leaving white traces on the black surface. Now, put a wide plate with a little vertical slit on it between the device and the blackboard and fire photons again. The balls start crashing into the plate, but some of them fly through the thin gap. They smash into the blackboard and leave a vertical white mark on it. Everything looks quite logical, but now cut another slit with the same length and thickness in the plate. You release photons toward the plate. Some of them fly through the two slits. What do you think the trace on the board should look like? Two white vertical stripes, right? Well, take a look at the board. It's covered with many vertical lines. When photons pass through the plate, they acquire the properties of a wave and crash into the board, leaving a strange trail, as if they've passed not through 2, but through 10 slits. So, at what point do they change their trajectory? Let's take a look. So, you stand between the board and the plate to see how particles turn into a wave. The device releases photons. They are passing through the two slits. Nothing unusual. There are 2 vertical traces on the board and no waves. You close your eyes and release photons again. This time they behave chaotically and leave many lines on the board. That is, their behavior changes depending on the observer. When you look at them, they behave logically, but when you don't look, the laws of physics seem to stop working. Does it remind you of anything? It's like you're playing a game and looking at the world around you, which is loading. But if you don't look, the world stops working. Scientists still don't have a clear explanation of why particles behave differently when there's no observer. Hey, maybe they're shy. And this is not the only mystery. In the world of quantum physics, many laws of nature don't work. This is a science that gets more questions than answers every year. If we imagine our universe as a large hologram, then quantum physics would be its program code. What if people someday understand this code and learn to change it? This would allow us to transform space, time, and matter. The whole reality could be rewritten. Does the code say that material objects can't exceed the speed of light? We would rewrite it and make the speed limit 100 times higher. Does 1 hour last 60 minutes? What if you change one line of code and make 1 second as long as 1 year? A few software changes in the laws of physics would make it possible to turn snow into gold and the ocean into powdered sugar. The whole universe would turn into a vast playground. It seems cool at first glance, but people would probably lose control soon. The universe would be in chaos, and the beauty of our world is in the order that exists here. Now let's go back to artificial intelligence. Suppose its power reaches the level of the human brain, and it will become aware of itself. In that case, it won't come as a shock to it because it will most likely know the history of its appearance and stages. But how will we react if people discover they are a computer program? A computer program is too simple a word. A human is a complex, intelligent, multifunctional organism that experiences emotions, contemplates beauty, has abstract thinking, and much more. The term creation is more appropriate here. It won't matter if we were created artificially because our creation will still be beautiful and complex. Besides, remember that good video games or apps can be made only if developers love their creations.
In the heart of the galaxy. Also, Sagittarius A star doesn't seem to have a very good appetite. It's been observed to be pretty quiet lately, which is good news for us. But even if it were super greedy, it wouldn't pose any threat to us. This black hole is over 26,000 light-years away. From Earth, we can see it in the Sagittarius constellation. In 2022, the Event Horizon Telescope collaboration released the first ever image of Sagittarius A star. It took years of collaboration and technology to capture this stunning image. And this is our second photo of a black hole in history. The first one was released in 2019, and it showed the supermassive black hole called M87 star. Yes, they both have star in their names. Don't try to make it make sense. Anyway, you may remember this photo as the first ever image of a black hole ever. It went crazy viral across the internet. And this black hole, M87 star, located in the Messier 87 galaxy, is way scarier than Sagittarius A star. You thought 4 million solar masses is impressive? Then how about 2.5 billion solar masses? M87 is a real monster. It's also known for its powerful jets of plasma, which are so energetic that they extend thousands of light years from the black hole's center. If M87 were a superhero, It would be Iron Man, with his repulsor beams on full blast. Now technically, you can't take a photo of a black hole itself, since it's, well, black. No light can escape its grasp. But the glowing orange ring in this photo shows the matter surrounding Sagittarius A star. It's called the accretion disk, a swirling disk of hot gas that spirals the center, heating up to millions of degrees in the process. It's like a giant fiery vortex, but with no escape. And the shadow in the center indicates the black hole itself. Inside that shadow, there's an event horizon. The event horizon is the boundary around the black hole, beyond which nothing, not even light, can escape its gravitational pull. It's the point of no return, where the gravitational force is so strong that even the fastest object in the universe, light, can't escape. Once you cross the event horizon, you're doomed to fall toward the center of the black hole, where the laws of physics as we know them break down. And this is exactly the fate that awaits our unfortunate X7. Right now, the pure blob is getting stretched and yanked by powerful tidal forces. By the way, before it meets its untimely demise, X7 is expected to put on a bit of a show. Its closest approach to the black hole, called periastron, is projected to happen in 2036. And when it finally gets torn apart by the Sagittarius A star's gravitational forces, there may be some cool fireworks to see. But this is not the most important thing. The funny part is, X7's future end may help us finally understand what the heck even is this thing. A team of scientists have been studying how a strange blob orbits the black hole. And that's when they discovered that X7 has stretched to almost twice its initial length. And what does that mean? Well, it suggests that X7 is most likely made of debris ejected during a recent collision between two stars. Yep, you heard that right, a space car crash. Imagine this. Two stars fall in love and start circling each other for many years. After that, they finally merge together. At this moment, they eject tons of gas and dust. And perhaps this cosmic dance created our blob baby, X7. It's basically like the crumbs left on the table after a giant space feast. Something like this is actually pretty common, especially around black holes. It's like a galactic fender bender that sends debris flying everywhere. Actually, the universe is full of mystery blobs. They're called the G objects. No, they're not the G-men from Men in Black, but they're just as mysterious and elusive. These guys have been puzzling astronomers for more than 20 years. They look like gas clouds, but behave like stars. It's like they can't decide whether they want to be a cloud or a star. Come on, guys, make up your mind. G objects stretch out at the closest point to the central black hole, but emerge intact, like a rubber band that stretches but doesn't break. Scientists think that they're the stars that have merged together into one. And while doing that, they also produce a huge cloud of gas that hides the result from view. Kinda like when you're wearing a bulky sweater, so that no one knows that you've put on a few extra pounds. And then a study published in 2021 found that one of these objects, G2, was actually a molecular cloud concealing 3 baby stars. Talk about a plot twist. But X7 is the black sheep of the strange blob family. It's significantly different from the G objects, like the weird cousin you see once a year at family gatherings. Its evolution has been more dramatic. Also, it's not being held together by a mass lurking in its center. So what is it being held together by? Pixie dust? Magic? We need answers! That's why scientists believe that X7 isn't a G object itself, but debris left from it. Or maybe not. We have no idea. The possibilities are endless, and that's what makes astronomy so exciting. So let's keep our eyes on the skies and see what other strange objects are out there. Who knows? Maybe we'll discover another mystery blob, and this time it's going to be a spaceship. Now that would be awesome.
Ooh, you're on a beautiful planet with unusual nature. Around you are ordinary people walking on this exotic planet. And now, get this, it's our new home. Humanity decided it was time to leave the Earth, and now we live very far away in another galaxy. But what happened to our home planet? Well, our solar system itself had an expiration date. It's been 7.5 billion years since 2020, and the Sun began to expand, absorbing planet after planet – Mercury, Venus, Earth. But the living conditions on Earth were unsuitable for us long before that. Let's go back there. In 4.5 billion years, our entire Milky Way galaxy will experience an incredible incident. The Andromeda galaxy will hit us at great speed. As a result of the collision, some stars will be thrown into distant space, while others will form new solar systems. But most likely, all life in the new Milkomedia or Milkdromeda galaxy will cease to exist. That's why people decided to pack up their things, get into new generation spacecrafts, and go to distant space in search of a new home. There can be an infinite number of planets in the universe on which humans can theoretically live. One of the main ingredients, the planet must orbit the star in its habitable zone. This means the temperature must allow the water to be liquid. We find similar star systems almost every year and have recently found the nearest one. It's Proxima Centauri. There are at least 2 planets around this red dwarf on which we can build our new home. But the problem is that this system is as far as 4.2 light-years away. So we had to open our garage and choose a vehicle that could take us so far. Saturn V is a rocket that used to take humans to the moon. It could reach the speed 30 times faster than the speed of sound. Today, we have more advanced technologies, like the SpaceX Falcon Heavy rocket. However, its speed is still about the same. It would take such a rocket about 113,000 years to overcome the distance to the closest star. So, you walk through the garage further and see the fastest human-made space object ever, the Parker Solar Probe. Its speed is a little less than 500,000 miles per hour, but it uses the gravity of the Sun to accelerate. Let's assume we can build a rocket that can reach this speed. Now, we sit behind a star map, do calculations, draw diagrams, and 6,600 years. And now, let's look at the photon. These are the tiniest particles that travel at the speed of light. And an obvious thought comes to your mind. How do you build a ship that can travel as fast as a photon? Well, until recently, travel at this speed was considered impossible. Fundamental laws of physics say that no object that has a mass can accelerate this much. Energy is required to accelerate mass. And to reach the speed of light, which is about 186,000 miles per second, we need an infinite amount of energy. But it's still too slow. Raise your eyes and look at the Sun. It's so close to us, but the light from it reaches our planet in 8 minutes, about the time it takes to go through the drive-thru and get your burger. And the journey to the nearest star will take 4.2 years. You can graduate from college during such a period. But we may have found a way to cheat the laws of physics and travel faster than light. Warp drive. It's a technology that manipulates space and time to break the laws of motion. In science fiction, it's a kind of field that envelops a spacecraft like a bubble or a shell and allows it to significantly exceed the speed of light. And we already have a similar technology, sort of. It's the Alcubierre warp drive. Since it's impossible to move at the speed of light in normal space-time, the ship must move by compressing the space in front of it and expanding it behind it. So not only the ship itself moves, but so does the space-time inside this bubble. In fact, this will allow the spacecraft to move at any speed, even 10 times faster than the speed of light. But to warp space-time, the ship must be simply humongous in size. It will need the quantity of energy comparable to the amount of mass energy of the whole planet of Jupiter. But at recent symposiums, scientists began to say that there is hope. In 2069, NASA plans to launch an interstellar mission to explore inhabitable planets outside our solar system. We do not yet know the details of this mission. It doesn't even have a name yet, but it will be dedicated to the 100th anniversary of the Apollo mission, the first man landing on the moon's surface. Here, near Pasadena, California, A small group of scientists from NASA's Jet Propulsion Lab are trying their best to make it happen, and their latest calculations have made everyone shout Eureka! It turns out the ring around the ship, which should create the so-called warp field, shouldn't be perfectly round as it was thought before. It's more like donut-shaped. This will greatly simplify the design and construction. And the best part, to test this technology, a spacecraft the size of Voyager 1 probe will suffice. Researchers are now aiming to reach at least 10% of the speed of light and launch the probe to Alpha Centauri. In this case, to overcome the distance of 4.4 light-years, the probe will need about 44 years. For comparison, the Voyager 1 mission was launched on September 5, 1977. In 43 years, it's traveled about 14 billion miles and is the most remote human-made object. It's also the loneliest one in the universe. It has long since left the boundaries of our solar system and is moving further into outer space. But rest assured, scientists have a couple more ideas in their secret laboratories. There are rumors now that they know how to reach the speed of light. The Space Association is considering launching small drones powered by lasers. Nuclear force, as well as collisions of matter and antimatter, can give enough energy to accelerate an object to the speed of light too. But their colleagues in a nearby laboratory are working hard to implement another technology, ion propulsion. It uses gas particles accelerated by the electric field. Simply put, your regular rocket is a daredevil on the road. He pulls the throttle to the max and burns an incredible amount of fuel to accelerate to the speed he needs. But ion propulsion is a careful old lady driving. She slowly presses the gas pedal and accelerates. On the scale of space, the old lady will have more efficiency and will be able to drive much further than the daring young man. Something we'll keep an eye on. Still, an unknown number of years will pass until there's a way to implement warp drive or ion propulsion. We want to make humankind interstellar, but first, we need to keep it alive at least. Now we're actively developing technologies to send the first manned mission to Mars. Colonization of Mars will be the first stage to make our species interstellar. It'll be a kind of rehearsal before colonizing distant planets. We must understand that although the conditions on the exoplanets may be close to earthly ones, we will still have to terraform them. We must test our technology on Mars to warm it up to the normal Earth temperature. We also need to increase atmospheric pressure so that water could exist in a liquid state, and create an ozone layer that will protect us from solar radiation. After that, we'll be able to breathe freely on the surface of Mars without spacesuits. We need to master all these technologies before we can create a real warp drive. Centuries ago, people sailed the oceans and perfected their ships to fully explore our planet. Now, we will be the generation to build new ships and go on long journeys outside the Earth. Warp drive will open up incredible horizons for us. Take a look at our galaxy. There are countless stars. Around each of them may be planets, and on some of them, there may be life. Warp drive will allow us to get in contact with this life and explore our galaxy much faster. And this future is already close. Soon, we'll have the chance to join the pioneers, put on beautiful suits, and travel the expanses of space in search of adventure.
Do me a favor, will ya? Try to imagine the first time you went camping. Maybe you went with your parents. Maybe it happened on a class field trip with your schoolmates. Regardless, try to picture, or remember, what it felt like as the day was coming to an end. The sun has set, but there's still some light outside. Let's say you were lying down, trying to rest for a bit. What's the first thing you remember seeing when looking up? If you're anything like me, it was probably the overwhelming number of stars twinkling right before you. These stars, most of which you can see without any fancy devices, are part of the Milky Way. Believe it or not, our amazing galaxy is almost as old as the universe itself. Age aside, it's also a pretty nice place to be. The Milky Way is like a cosmic nursery where new stars are born. And let me tell you, it's home to some of the most fascinating places, at least from what we can see in pictures. Take the Mystic Mountain. an area in the Carina Nebula. Here, things are always splashing and full of energy. That's because of gas columns collapsing and creating crazy opposing jets that are thrown around like acrobats in a circus. It's like a signature move for stars being born, you know? And if you take a look at this awesome picture, you'll see the elements putting on a colorful show. Blue represents oxygen, green is for hydrogen and nitrogen, and red is the sizzling sulfur. Ready for our next stop on our ride through the Milky Way? Check out these huge, twisted clouds of interstellar dust and gas hanging out in the center of M16, also known as the Eagle Nebula. We've got ourselves the super cool Pillars of Creation, which are like towering columns where brand new stars like to hide and chill. Now, I know this ain't the first time the Hubble telescopes captured this epic sight, but trust me, this is the most mind-blowingly detailed image yet. The pillars are getting showered with crazy hot ultraviolet light from a bunch of young stars hanging just outside the frame. These stellar superstars are actually causing the towers of dust and gas to gradually get worn away by their gusty winds. Brace yourself for the numbers, too. These pillars of creation stretch out for about 4 to 5 light years. Yeah, it sounds big, but in the grand scheme of things, they're kind of like the cute little siblings of the larger Eagle Nebula, which spans a whopping 70 by 55 light years. The nebula was first spotted back in 1745 by an awesome Swiss astronomer, and it's about 7,000 light years away from our humble abode, in the constellation Serpens. Here's the quirky part, though. As productive as it might sound, the Milky Way's star-forming activity is quite rare when compared to other galaxies. Astronomers have noticed that the pace at which stars are being born is actually dropping, and they're itching to figure out why. But before we can dive into this weird phenomenon, let's look at how stars come into existence in the first place. It's hard for us to know for sure from down here. What we can gather about a star's life cycle comes from looking at those within our local Milky Way. Stars are formed in colder clouds of gas and dust called nebulae. These areas are pretty common throughout most galaxies. These nebulae have low temperatures that are crucial for hydrogen gas to stick together. As the clump gathers more gas, it causes movement, which itself creates energy. When more gas collides with the already formed clump, all that energy transforms into heat. This keeps going until the temperature grows considerably, sparking the birth of a star. The most secure time of a star's life is also known as its main sequence. I'll spare you the chemistry lesson, but during this time, the star produces both heat and radiation. It's because of the radiation that there's pressure around a star, and it's also the reason for most of the light found in a certain galaxy. Now let's talk star sizes. The bigger the star, the faster it consumes its fuel. These massive stars shine the brightest, emitting high-energy UV light. On the other hand, lower mass brighties live longer, despite not being as shiny as their larger siblings. There's a variety of star sizes in most galaxies we're able to see from down here. Some stars are 0.1% the size of the Sun, while others have 10 times its mass. Once a star finishes up its fuel, it welcomes its grand finale and transforms into a faded star. Stars about the same size as the Sun or smaller can no longer produce radiation at this stage. Gravity takes over, causing their matter to settle into a white dwarf. For bigger stars, the timeline changes a bit. They too collapse, but there's a lot more stuff burning, and it's also hotter in there. This collapse creates a stronger core. When all of the star's insides are done for, the outer layers collapse in a jiffy. It bounces off the core at nearly the speed of light. It's an impressive, explosive event called a supernova. The blown-out material becomes the basis for future stars. It also leaves behind a black hole. Now that we know a bit about a star's life, let's try to look at each generation, if you'd like. Stars don't just pop up constantly at the same rate. Currently, the universe is manufacturing only about 1/9 the number of stars compared to its star-forming glory days, which happened roughly 10 billion years ago. One study gave us a peek on the history of star forming. In writing it, 2 scientists teamed up to gather a ton of data about galaxies. They sorted these galaxies based on how far away they were. By doing this, they could track how the brightness of galaxies has changed over the universe's lifetime. Since stars give off most of a galaxy's light, they could use that brightness to figure out how many stars were forming using some fancy math. Their findings confirmed that star formation was pretty wimpy when the universe was young. But as gas started to gather in galaxies, boom! Star formation skyrocketed until about 10 to 11 billion years ago, when it hit its peak. After that, star formation took a nosedive. In today's observable universe, it's dropped a lot. That means around 50% of the stars we see today were born in the first 5 billion years post-Big Bang. A mere quarter formed in the last 6 billion years. So what's causing this cosmic shift? Well, scientists think it's all about that cold gas that stars need when they're born. When galaxies form, the gas gets concentrated inside, leading to a star formation extravaganza. But then, the gas is used up quickly as stars doze off. When supernovae come into play, they blast away that much-needed gas for future star making. Not to mention, it also changes the chemistry of that gas. This crucial piece of information could be a starting point for the star-making decline we see today. Scientists are still not sure why this gas becomes useless. Galaxies are also pretty complex to begin with. There are all sorts of forces involved in maintaining their balance. For instance, when a supernova goes boom, the shock waves can sometimes cause turbulence and clumping of the gas, sparking the birth of new stars. But if the supernova is too wild, it can blast that same gas right out of the galaxy. With no gas left in the area, there's little to no chance a new star could form. Now, what does the future hold? Some scientists can't help but wonder what might happen if no new stars pop up. The universe might be simply filled with black holes and fading stars. Solar systems would become inhospitable as their stars lose power, and those ravenous black holes might munch on whatever material is left. As gloomy as it seems, you do have to admit it's a mind-boggling concept. Luckily, we don't have to worry about it happening anytime soon. The universe is a whopping 13.7 billion years old, but the dark era isn't expected to kick in until somewhere way further in the future. But hey, this is just one possible outcome of the decline in star formation. Who knows what other wacky possibilities the universe holds?
Well, here's a fun question for you. Could black holes actually be wormholes? In other words, what if black holes are secret doorways to other parts of the universe? And if you fall into one, you get teleported into another galaxy, just like in sci-fi movies. Well, let's see if that could work. Black holes are incredibly heavy and dense celestial objects. They're like whirlpools in a bathtub, but on a space scale. Everything that gets too close to them, including planets, stars, and even light itself, gets sucked in, and nothing can get out. They're born when a big star gets super old and eventually collapses onto itself, leaving behind a small super-dense core. If this core is massive enough, it becomes so powerful that gravity takes over everything and we get a black hole. Black holes, despite the name, are not at all empty. Instead, it's like having a giant amount of stuff squeezed into a very tiny space. Picture a star way bigger than our Sun, packed into a sphere about the size of New York City. This creates such a strong pull of gravity that absolutely nothing can escape from it. NASA has been using special tools to learn more about these weird things. Since they're, well, black, we just can't find them by looking at telescopes. But we can figure out that they're there by watching how they affect other stuff nearby. For example, when a black hole moves close to some space dust, it sucks the dust in. This process is called accretion. It's kind of like when you vacuum up dirt. When this happens, the matter speeds up and gets super hot, emitting X-rays that we can see. Okay, now that we know what black holes are, let's talk about wormholes. Imagine a wormhole as a tunnel in space that could let us travel quickly to faraway places in the universe. They connect two different points in space as if it were a sheet of paper that can be bent in half. Basically, they're intergalactic teleports. This idea comes from Einstein's theory of relativity and involves folding space and time. In the early 1900s, he and others thought about the possibility of these shortcuts and called them wormholes. So far, we don't know if they exist. We see them in sci-fi movies often, looking like a big round opening. But the problem is, if they're real, they could be incredibly tiny, smaller than even a grain of sand, and they might not last long, collapsing before we could even use them. To make matters even more complicated, you need a special kind of matter, which we haven't seen in the universe yet, to keep the wormhole stable. Regular matter won't do the trick. And even if we could find and create a big wormhole and make it stable, it's not clear if humans could travel through it. Some scientists think the law of physics might not allow it. But, just maybe, in the future, with incredibly advanced technology, we could figure out how to use these space tunnels for travel. Until then, wormholes are mostly in the realm of imagination. So, could one thing be another? Some scientists think that it might be possible. A team of researchers from Sofia University in Bulgaria suggests that some black holes might be wormholes. The biggest question for scientists is, where does all this stuff that falls into a black hole go? And here's where they introduce the idea of something called a white hole. Well, as you can guess, it's like the opposite of a black hole. Instead of pulling things in, it constantly pushes them away. If we looked at one, it would look like a super bright fountain that constantly spews out matter and energy. Just like regular black holes, they should have properties like mass, charge, and how they spin. They pull things toward them because of gravity. But if something fell towards a white hole, it would never actually reach it. This is because they don't have a surface like the ground we walk on. Instead, their gravity gets stronger and stronger, but there's no surface to land on. As we mentioned before, scientists believe that supermassive black holes are at the center of every galaxy. Some have suggested that they might give birth to supermassive white holes. However, this is just a theory and not proven. The idea of white holes was first suggested in the 1960s as one of the solutions to Einstein's equations. This solution describes a black hole that lasts forever from the viewpoint of someone inside it. But black holes are formed when massive stars collapse, so they have a different structure. So now, imagine if these black holes and white holes were connected, forming some sort of space tunnel. One end of this tunnel sucks everything in, and the other pushes everything out. Well, guess what it would be called? However, this wormhole wouldn't be as cool as it sounds. Just like regular wormholes, these ones would be super fragile, like a very stretched rubber band that snaps easily. Researchers believe that, if that's the case, these wormholes might look remarkably similar to the black holes we already know about. In fact, they say it's incredibly tricky to tell the difference. The light and radiation coming from the swirling matter around a black hole could be the same as what we'd see around a wormhole. So for now, all of this is purely theoretical. To see if they're right, we'd have to prove the existence of white holes themselves. But hey, while we're at it, let's dive into another hypothetical scenario. What happens when we bump a wormhole and a black hole into each other? Ooh, what fun! Scientists think they might spot this unusual event by looking for something called gravitational waves. These waves are like ripple in the fabric of space and time, caused by massive things moving around. And as we all know, black holes are the heaviest things around. Imagine that you have a spinning top on the surface of the water. If you spin it slowly, waves that come from it would have a larger, lower frequency. And if you start spinning it very quickly, the waves around it will be very frequent. This is exactly what happens when a heavy object dances in space. Black holes create gravitational waves as they spin. And the faster they do that, the higher the pitch of the sound they make. In space, this sound is like a chirping noise. So, picture a black hole falling into a wormhole. At first, you'd hear a chirp as it approaches the wormhole. While a black hole circles around, it would create another interesting pattern of gravitational waves. But when it gets sucked in and reaches the center of the wormhole, the waves suddenly stop in one part of the universe. And as it comes out the other side, the chirping would change into an anti-chirp. They would appear and disappear as the black hole goes in and out of the wormhole. This pattern would repeat as the black hole goes back and forth. As the black hole keeps bouncing between these two parts of the universe, it would produce bursts of gravitational waves followed by silence. Now, if scientists detect these unique gravitational wave patterns, it could be a clue that wormholes really exist. This unique chirp and anti-chirp could be a clue that a black hole has fallen into a wormhole. But that's just the theory, since wormholes are very speculative and still a big mystery in science. So while this idea is cool and could help prove the existence of wormholes, it's still a big maybe. In any case, we'll need some super advanced telescopes or very clever tricks to tell the two apart and see if wormholes are real at all. But until then, it's all a fascinating mystery. And truthfully, I'd rather not fling myself into a black hole to find out.
Woohoo!
Oh, fasten your seatbelts. We're setting course for the most bizarre places in our universe, and you'll see the most mysterious phenomena few people have ever seen before. Recently, astronomers have discovered that the supermassive black hole at the center of our home Milky Way galaxy might be leaking. Why is it a significant change? Because it might mean that this black hole, called Sagittarius A star, whose mass is 4.1 million times the mass of our Sun, isn't a sleeping giant as previously thought. It might still be active. And the leakage, recorded by scientists, may be the hole hiccuping while swallowing clouds of gas. Hey, I've been known to do that from time to time. During the research, the team of astronomers used the Hubble Space Telescope. It helped them spot a jet that looked like a blowtorch. It was pushing into clouds of hydrogen at the center of our galaxy. The jet seemed to spew gas like a hose directed into a pile of sand. This often occurs around other active black holes surrounded by the material drawn to them by their immense gravitational pull. Some of this material gets pulled into the black hole, but a small part of it gets swept outward by powerful magnetic fields. The research suggests that when a giant gas cloud gets too close to our supermassive black hole, it gets swallowed, and then the hole belches small jets of matter. Fermi bubbles might be the result of the belches that occurred around 2 to 4 million years ago. But recently, scientists have found another giant glowing bubble of hot gas. It aligned with the jet stretching for 35 light-years or more from the supermassive black hole. Astronomers suspect that the jet could have plowed into this bubble of gas and inflated it. Now, let's visit some other breathtaking places in our universe. But be careful, some of them are extremely dangerous. Like this rotating neutron star called the Black Widow pulsar. Just like its spider namesake, it's munching on its partner, a lightweight brown dwarf star. The more material this pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. If it does exist, nuclear pasta is the strongest material in the entire universe. Formed from the leftovers of extinguished stars, this substance gets squeezed into spaghetti-like tangles of material. It can break, but only if you apply 10 billion times the pressure needed to shatter steel. How about visiting a planet where it rains glass? Nah, I'd rather not. You see, this bright blue exoplanet looks peaceful and slightly familiar. Don't you think it slightly resembles Earth? But this pretty appearance hides the planet's terrifying nature. The winds blow at 5,400 miles per hour on its surface. That's 7 times the speed of sound. But that's not the worst. It rains glass sideways in this scorching hot alien world. Solar tsunamis are a solar phenomenon dubbed Terminator events. These tsunamis take place at the sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen every decade or so. Now look at this space body. Its nickname is Electric Hyperion. This Saturn's moon is one of the most bizarre-looking moons in the solar system, but its appearance isn't the strangest thing about it. This pumice stone-like rock, pockmarked with countless craters, is also charged with static electricity, and it's flowing out into space. Look at this, a rogue planet with auroras. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars. But one of them, 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates flashing auroras in the planet's atmosphere. Be sure to stay away from black holes. Do I really need to warn you? Yep, they're some of the most perilous objects in the universe. But how about mini black holes? Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have the mass of 1,000 sedans. One theory claims that tons of micro black holes could have been created right after the Big Bang and the beginning of the universe. Some scientists even go as far as to say that a couple of mini black holes pass through our planet every day. Ooh, I'll bet you like our next stop, a burning ice planet. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means it's traveling remarkably close to its parent star. That might be the reason the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X, which remains solid despite blistering temperatures. Now, if you love jewelry, this next world is for you, a diamond planet. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. This in turn might mean that at least some part of the planet is diamond. Moons orbiting other moons might exist, or they might not. Astronomers haven't agreed on this one yet. Planets orbit stars, and moons orbit planets. But then, why can't there be moons, also known as submoons, moonettes, and moons? It actually sounds like one of those flowery Hawaiian dresses, moo-moos. But alas, no. Researchers claim that moons could exist, but the host moon has to be massive enough, the moon small enough, and there must be a wide gulf between these moons and the host planet. Now, I'll take you to the living fossil galaxy. DG-SAT-1 is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DG-SAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, this galaxy is a real living fossil. Now, you won't be able to see the next space phenomenon, all because people can't see infrared light. And the phenomenon I'm talking about is an infrared stream from space. Ooh. Neutron stars are ultra-dense collapsed cores of giant stars. They usually emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. This signal was probably generated by a disk of dust surrounding the star, but this theory hasn't been proven yet. Behind the orbit of Neptune lies the mysterious Kuiper Belt, filled with massive icy objects. The most curious thing about this space formation, though, is that scientists fail to explain the pattern of its movement. The only explanation they have is that Neptune might be hiding from our sight a ginormous planet. This hypothetical planet has already got the name Planet 9, and all we have to do is wait until its existence is confirmed, or not. Let's visit our star, but we need to be careful not to come too close, because the Sun's atmosphere is hotter than the surface of the star. While on the surface, the temperature reaches 10,000 degrees Fahrenheit, the upper atmosphere heats up to millions of degrees. Scientists suspect that explosive bursts of heat from the Sun may have something to do with this unique phenomenon. Now, this space object is also worth visiting. Haumea, a dwarf planet orbiting in the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning big object in our solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Ring-a-ding-ding.
25 light-years away from Earth, in the constellation Lyra, there's a young star, Vega. The brightest and one of the most famous, this star is twice the mass of our Sun. Vega is so brilliant, you can see it even at twilight when all the other stars disappear from the sky. Despite all the star's fame, astronomers have never seen a single planet orbiting Vega, until recently. Researchers have been observing the star for a decade or so when they spotted a curious signal. It might be Vega's first world we'll know about. If it did exist, it'd be a marvelous place. The planet would likely orbit so close to its host star that one day on it would last around 2.5 Earth days. The world would be the size of Neptune, and this ice giant is 4 times wider than Earth. Or it might even be as large as Jupiter. But the most impressive thing about this potential planet would be its temperature. The place could turn out to be the second hottest world known to scientists. On its surface, it'd be as hot as 5,400 degrees Fahrenheit. For comparison, the temperature on the surface of the hottest planet in the solar system, Venus, doesn't rise above 900 degrees Fahrenheit. The only place hotter than Vega's potential companion would be Kelt 9b. The temperatures on this exoplanet don't drop below 7,800 degrees Fahrenheit. Anyway, the candidate world would be closer to Vega than Mercury in our solar system is to the Sun. It could result in the giant planet puffing up like a balloon, and then even metals would melt in its scorching hot atmosphere. Unfortunately, the existence of the sizzling planet has yet to be confirmed. Astronomers think that the easiest way to prove it is by trying to spot the light emitted by the unusual planet. And since we're talking about planets, are there any worlds out there that resemble Earth? Astronomers have discovered and confirmed more than 4,000 exoplanets, but it's no secret that thousands of other candidates are still waiting for their turn to be detected. Of course, not all of these planets are like our Earth, but some are. For example, Gliese 667cc. This world is only 22 light-years away from Earth. Scientists aren't sure if the planet is rocky, but they know the place is more than 4 times as massive as our planet. The star of Gliese 667cc is a red dwarf. That's why it's much cooler than our Sun. So, the exoplanet is likely to be in its star's habitable zone. But this idea hasn't been confirmed yet. The Earth-like planet might be moving too close to the star. Then it can be regularly baked by its flames. Kepler 22b is much farther away than the previous world. If you wanted to reach that planet, you'd have to travel 600 light-years. This world, which is more than twice as large as the Earth, lies in the habitable zone of its host star. But it's unclear whether it's liquid, gaseous, or rocky. Kepler 69c is almost 70% bigger than our planet. It's also very, very far away, 2,700 light-years. It'd take you 54 million years to travel the distance that great in a modern spacecraft. Researchers aren't sure what Kepler 69c consists of, but they think it's likely to lie in the habitable zone. The planet's position in its solar system is like that of Venus and ours. But since the host star is only 80% as bright as the Sun, the planet shouldn't be affected by its heat that greatly. Kepler 452b is the most Earth-like planet astronomers have discovered so far. It resides 1,400 light-years away from our planet. Its host star is very similar to our Sun, and the planet, lying in its habitable zone, is 1.5 times the size of Earth. Scientists also think that Kepler 425b is likely to be a rocky world. Are any of these or other planets besides Earth suitable for life? There are 24 potentially super-habitable planets, and one of them met not one, but two criteria astronomers have for such worlds. KOI 5715.01 is 5.5 billion years old and around twice the size of Earth. It orbits an orange dwarf a bit less than 3,000 light-years away from our planet. Its surface temperature might be 4 degrees Fahrenheit cooler than that of Earth. But since the planet's atmosphere might have more heat-trapping gases, the place is likely to be super-habitable. Another potential super-habitable planet is KOI 5554.01. This world is a bit older than our planet, 6.5 billion years against our 4.5 billion. The exoplanet's size is likely to be the same as Earth's. The planet orbits its host star, a yellow dwarf, and the average temperature on its surface is 80 degrees Fahrenheit. What planets are visible from Earth? Mercury is the nearest to the Sun in our solar system, but since this planet is so close to the star, you can only see it just after sunrise, in the early morning, and at dusk. From up close, the place looks a bit like the good old moon. The planet doesn't have an atmosphere, and the temperatures on its surface are extreme, 800 degrees Fahrenheit during the day and minus 290 degrees Fahrenheit at night. Venus is the second brightest celestial object out there after the moon. It's one of our planet's closest neighbors. Also, it's the most similar to Earth in terms of gravity, size, mass, and average density. Unfortunately, you won't be able to see Venus's surface from Earth. A thick layer of clouds is securely hiding the planet. Jupiter can be either the third or fourth brightest object in the sky. It depends on Mars, which occasionally shines brighter than the gas giant. You can see Jupiter especially well in the summer. The gas giant's most famous feature is the Great Red Spot. That's an enormous storm that has been raging on the planet's surface for centuries. Even though the largest planet in the solar system looks like a solid sphere, you wouldn't be able to land on its surface. Jupiter is mainly made up of gases, mostly helium and hydrogen. Saturn is the second largest planet in the solar system. It's the last one of the 5 planets you can see from Earth with the unaided eye. Saturn is incredibly far from Earth, but its unique rings help you instantly recognize this colossal planet. It's a pity that Saturn's trademark feature is only visible in a telescope. By the way, more than 700 Earths would fit into Saturn. At the same time, the gas giant's density is a mere 1/8 of Earth's. This is why Saturn's mass is just 95 times greater than that of our planet. What planets in the solar system are closer to each other than the rest? Astronomers believe that Mercury is the closest to any other planet in the solar system. And that's quite shocking because, how about Venus? It orbits the Sun between Mercury and Earth. Isn't it supposed to be closer to our planet? Venus is indeed rather close to Earth, but only for a very short period in its orbit. The rest of the time, Venus is much farther away. But Mercury's orbit doesn't let the planet move too far away from the Sun, and it's closer to Earth more than 50% of the time. The same principle works with other planets too. Even gas giant Neptune is farther from Uranus than from Mercury. Most of the time, the two larger planets are on the opposite sides of the solar system. Their orbits sometimes do bring them very close to each other, but it happens very rarely. And how about planets outside the solar system? Astronomers have recently discovered 2 worlds traveling around the same star. Their orbits are often so close to each other that each planet looks like a huge full moon from the surface of the other. It occurs every 97 Earth days. These planets are about 1,200 light-years away from Earth. Their composition and size are different, but the distance between them is a mere 1.2 million miles. That's 5 times the distance between Earth and the Moon, and it's closer than any other planets astronomers know about. One of the newly found worlds is more than 4 times as massive as our Earth. It's likely to be rocky. The other is a gaseous planet the size of Neptune and almost 8 times as massive as our planet. Scientists haven't figured out yet how such dramatically different space bodies ended up in such similar orbits.
We've been focusing on trying to find life on Mars so much, while there is this gem waiting to be explored. This planet is the 6th farthest from the Sun and the 2nd largest in the solar system. You'll find it right behind Jupiter. I'm talking about Saturn, or as they sometimes call it, the jewel of the solar system. It's so different from our planet. First of all, you wouldn't be able to stand there. While Earth consists of rock and other tough stuff, this planet is like a giant ball, mostly made of gases. If you found a swimming pool huge enough to fit Saturn, you could see the planet floating in the water. No wonder, Saturn is the least dense planet in the solar system. It also contains a lot of helium. You know, the gas you put in balloons to make them hover in the air. Saturn is a very windy planet. Winds there are more than 4 times stronger than the ones we have on Earth. A day over there lasts 10 hours and 14 minutes because Saturn spins on its axis pretty fast. But the planet takes its time while going around the Sun. A year there equals 29 Earth years. Saturn's radius is more than 36,000 miles. It means the gas giant is 9 times wider than our planet. If Earth was the size of a nickel, Saturn would be as big as a volleyball. Even though some of our planets in our solar system also have rings, Saturn's are the most spectacular ones. You can even see its rings from Earth. And no, you don't have to be a scientist with insanely expensive equipment. All you need is a small telescope. Saturn's rings are not firm. They are made of pieces of dust, rock, and ice. Some of them are as small as grains of sand, and some as big as a house or even a mountain. These are actually bits of asteroids, comets, and shattered moons that fell apart before reaching Saturn. They could be torn into pieces by the planet's powerful gravitational pull. Saturn has over 50 moons, and recently, scientists have discovered some unusual hydrothermal activity on one of them. Enceladus is Saturn's 6th biggest moon. It has 4 tiger stripes close to one of its poles. Researchers have found that there is an ocean underneath these stripes. Water and ice erupt from that area, so now we can't but wonder, maybe there's life out there. In the oceans on Earth, some forms of life gather around similar hydrothermal vents. They feed on the chemicals there, same as plants on the surface do with sunlight. And not only that, some of the oldest microbial life on our planet feed on the same energy as the one produced beneath the ocean's surface on Enceladus. It could potentially mean there's life developing there right now. Of course, it takes millions and millions of years for even the simplest organisms to appear. But hopefully, scientists will need less time to find more complex forms of life. There are millions of exoplanets out there in space, and scientists have been searching for those that could be potentially habitable. Exoplanets are planets orbiting a star outside of our solar system. Dwarf stars are similar, less luminous than the Sun. They sometimes live for more than 10 billion years. That's enough time for a living organism to develop and evolve into a more complex form. Life might appear on the planets orbiting such dwarf stars, or, like with Saturn, on one of their moons. And here it is, Gliese 876b, that orbits the red dwarf star Gliese 876. This planet is mostly a mystery, but scientists assume this is a gas giant that has no solid surface. They believe its atmosphere doesn't have clouds, but there might be water in its liquid form on the planet's surface. T Gardens b orbits a red dwarf that's around 12 light-years away from our solar system. The planet's mass is just a bit higher than that of Earth. Scientists think it may have a rocky surface. The planet needs around 5 days to complete its orbit. It means that 1 year on T Gardens b is actually shorter than 1 week on Earth. Somewhere far, far away, there's another potentially habitable planet named Kepler 1638b. Okay, to be more precise, it's 3,000 light-years away from Earth in the constellation Cygnus. This planet is 4 times as heavy as Earth and twice as wide. It needs almost 260 days to complete 1 orbit around its star. The gravity on this planet is stronger than that on Earth. It wouldn't be an easy feat to jump on its surface. One more Kepler coming along. This time, it's Kepler 62e, a planet that's more than 1.5 times the size of Earth. Scientists believe this one has a warm, humid, and hospitable atmosphere with cloudy skies. There are 1,200 light-years between Earth and this planet. Kepler 62e needs 122 days to orbit its red dwarf star. Its neighbor, Kepler 62f, is another potentially habitable zone. It's a world around 40% bigger than Earth. Scientists think this planet might be covered in water. The oceans on our planet are full of interesting creatures and organisms of all sizes, so the chances are this planet also hides some intriguing living beings, or at least it has the potential to develop life. When we say habitable, it doesn't mean life definitely exists there. It just means there are conditions for some forms of life to develop. LHS 1140b is a planet located in one of the potentially habitable zones. Unlike its gas companions, it's solid and quite rocky. The planet's radius is 60% larger than that of Earth, and its mass is 7 times bigger. It's one of the densest planets found out there. Since the planet has a big mass, an atmosphere there must be rather thick. Plus, gravity on its surface is much stronger than here on Earth. That's why you would likely have problems just standing on that planet. Hello and greetings from TRAPPIST-1, an ultra-cool dwarf in the constellation Aquarius. It's around 39 light-years away from us. 7 Earth-sized rocky planets are orbiting in the star's habitable zone. All of them can potentially have some water on their surfaces. The temperature on these planets is more or less similar to that on Earth. On the Moon, gravity is only 16% of what we have on our home planet. That's why the astronauts could hardly control their movements when they visited our natural satellite. But when it comes to the gravity on TRAPPIST-1 planets, you would probably feel good and comfortable there. And Kepler, once again. This time it's Kepler 452b. It's a rocky planet 60% larger than Earth. Its parent star is similar to our Sun. This planet has actually spent around 6 billion years in the habitable zone, while Earth has been there for a mere 4.5 billion years. This planet needs 385 days to orbit Kepler 452. This star is around 20% brighter than our Sun, but has the same temperature. The whole system is very far from our little oasis. It would take you 28 million years to get there. And now, how about KOI 7711.01? It's another intriguing world 1,700 light-years away from us. This planet is only 30% bigger than Earth. It gets almost the same amount of heat as we receive from our Sun. Sometime in the future, people might start colonizing the galaxy. They would be looking for new planets to live on. Then we'd certainly have to make really long trips, and maybe one day we'd reach Proxima Centauri. It's a nearby star that has a couple of planets we could potentially inhabit, like Proxima Centauri b. It's around 4 light-years away from Earth, and it doesn't sound that far at first, but it actually is. It would take about 6,300 years to travel there, if we use the technologies that are available these days. It would mean many, many generations to make a trip like that, and it would take even longer to finally inhabit that new world. People would be born and raised on spaceships. They would live their lives there without ever seeing either Earth or the planet they're heading to. Instead of trees, mountains, and rivers, there would be only the dark nothingness of faraway galaxies spreading in front of them. They would never be able to wander unknown streets, breathe in the fresh air, feel the wind. The only place for them to travel to would be another part of the ship. Certainly, such a journey wouldn't be simple, but it would pay off if people managed to build some more beautiful worlds, like the one we have here on Earth. Is that even possible? Time will tell.
We've discovered Kepler 22b, a small exoplanet in the Cygnus constellation. Seems like nothing important, right? But it's actually a big deal. This is the first planet located in the habitable zone that was found by the Kepler telescope. In other words, there may be water on this planet, and if there's water, there may be life. Kepler 22b can become our new potential home. So let's take a closer look at it. Actually, discovering new planets is not easy at all. Not all of them can be seen through our super cool telescopes, even the almighty Hubble. Sometimes, the stars are so small and dim that it's really hard to find them on a map. The same thing happened with Kepler 22. In such cases, scientists have to use a special method. First, they take a bunch of photos of the star in different periods of time. Then, they look at them and think, are there any dark dots on this star somewhere? And if they find one, that might be a planet. These photos actually help us to discover some very important stuff. Like, first of all, this planet exists. Secondly, here is its size, radius, and proximity to the star. And finally, will we be able to live there? Now we know that Kepler 22b is very similar to our planet and could potentially become a second Earth. It's also very close to us, only 635 light-years away. Yeah, it's about 3 quadrillion miles, but this is one of the closest options. Kepler 22, the star of Kepler 22b, is a yellow dwarf. It's very, very similar to our Sun. The same size, the same radius, even the age is almost the same, 4 billion years. The difference is only in luminosity. It's about 20% dimmer than the Sun. So, no matter how much you strain your eyes, you won't see this star in the night sky. The planet Kepler 22b is about 2.4 times larger than our Earth, and that's pretty good. More radius means more potential water and space to live. Although going from one city to another would take a while. It's scary to even imagine a 3-day-long plane flight. We don't know the exact mass of this planet, but scientists think it's bigger than Earth's. Actually, the mass of Kepler 22b can be up to 36 times greater than that of our planet. What does it mean? Vigorous gravity. If the planet is 36 times heavier than Earth, then gravity there will be about 6 times stronger. Can you barely lift 20 pounds of potatoes? Try 120. Not to mention that you yourself can become much heavier on that planet. You'll have to get incredibly pumped up just to walk there. You have to literally turn yourself into a bodybuilder just to get to work. The worst thing is that with such gravity, it'd be incredibly difficult for plants to survive there. They'd need at least a little freedom to rise up from the ground. And animals. Our dogs and cats would have to turn into little balls of muscle to survive there. But if this planet has its own animals or other inhabitants, we can roughly imagine what they may look like. They probably have a lot of legs to make moving easier. They aren't really tall, but they're very massive and extremely strong. Muscular giant spiders? Could be worse, I guess. The good news is that this is all unconfirmed information. If we're very lucky, and gravity there turns out to be just a bit stronger than Earth's, then, of course, it'll be much easier to live there. The next thing we know about Kepler 22b is that it's about 15% closer to its star than we are to the Sun. If Kepler 22b existed in our solar system, it would be located somewhere between Earth and Venus. Does that mean we're all going to burn? No, silly. As I mentioned before, the star Kepler 22 is pretty cold, just some 10,000 degrees Fahrenheit. And that's why we can assume that the temperatures on Kepler 22b will be about the same as we have on Earth. If the planet orbits its star the same way Earth orbits the Sun, which we don't actually know, Kepler 22b can rotate around its star on its side, like, for example, Uranus. What? Didn't you know Uranus is actually lying on its side? Also, look at its rings. Yes, Uranus also has rings, like Saturn, but they're vertical. The universe is truly a mysterious place. So, if Kepler 22b is really something like that, then the weather on the planet will be, to put it mildly, not very good. Incredibly cold winters will be regularly followed by hot summers. And, just like with tidally locked planets, we'd be able to live more or less comfortably only on the narrow piece of land between these two crazy sides. Let's hope that this is not the case and the planet rotates normally. But it's not all that bad. Studies show that there may be an ocean on Kepler 22b. You already know that water means life, but in this case, it's also a big plus because a planet covered by an ocean always has more stable temperatures. The water absorbs some of the heat and distributes it evenly across the planet. The hot parts cool down, and the icy ones warm up. By the way, that's exactly what happened to Earth billions of years ago. When our planet started getting its first little puddles, our beloved moon helped these puddles to spread all over the planet. Thanks to this, a burning horror that used to be our Earth turned into a cute little ball full of life. So, if Kepler 22b has water but no atmosphere, scientists think that the average temperature there could be around 12 degrees Fahrenheit. But if there's also an Earth-like atmosphere, then the temperature can reach 72 degrees Fahrenheit. That would be nice. And finally, 1 year there is equal to 290 Earth days, about 9 months. The planet has no natural satellites, so unfortunately, we'd have to say goodbye to a beautiful view of the moon. On the bright side, we'd probably be able to see the sun as a distant little star. We could admire it in the night sky, remembering our home. Well, not hiding from giant spiders. And this is all that we know at the moment. Unfortunately, it's quite difficult to explore such planets, so there's a lot of very important data that we don't know. For example, what kind of planet is this anyway? Yep, we're missing the most important information about Kepler 22b. We don't know if it's a rocky planet or not. And if not, then all the previously mentioned information means nothing. It may turn out to be a gas planet, or a planet covered with gas but with a solid core, like Neptune, or a water world covered with a giant ocean. In this case, it better be a water planet. Then at least we could build some kind of underwater city there. We could filter the water and eat fish, until we evolve into an amphibious species. Does it even count as evolution if we go back to our roots? Scientists, however, think that Kepler 22b may turn out to be a Neptune-like planet. Some astronomers have even assigned the planet to a category of mini-Neptunes. Yes, this is a real planetary category. But this hasn't been proven yet. But even if, fortunately for us, Kepler 22b turns out to be a rocky planet, we still don't know what the atmosphere is like there. Does it exist at all? What if it turns out to be something like the atmosphere of Venus, which is more toxic than your ex? Then we'd have to dig deep underground to somehow survive on this planet. And then we'd have to come up with a heat source, because it's pretty cold underground. Yeah, let's hope this won't be the case. There are many possibilities with Kepler 22b. So far, we don't have a clear answer. But let's hope that scientists will find it before we load the first people into shuttles and send them to conquer Kepler 22b. That would be awkward if it turns out to be a gas planet, or something like that.
Saturn's iconic rings will disappear in less than 2 years. Soon, we won't be able to see Jupiter's Great Red Spot. Pluto's atmosphere might vanish any day now. Even the universe itself could be slowly evaporating right at this moment. But let me start from the very beginning. Saturn's rings won't vanish forever, at least in the near future, but they will seemingly disappear from view. This phenomenon is caused by the planet's tilt as it orbits the Sun. As a result, the eye-catching rings adorning the gas giant will get invisible to stargazers in 2025. This outrageous disappearance occurs because Saturn's thin rings turn edge-on. It's like holding a sheet of paper horizontally at eye level parallel to the ground so that only the edge of the paper can be seen. Something similar happens to the gas giant's rings. As the seasons on the planet progress, instead of the southern side of the rings tilted our way, we start seeing the northern side. But then the planet tilts again, revealing the southern side once again. Such a ring plane crossing happens every 15 years when our planet passes through the gas giant's ring plane. The last time this phenomenon occurred was in 2009. Afterward, the rings gradually became visible again over the course of several months. This time, the rings will be on edge in March 2025. Then they will slowly come back into view and disappear again in November of the same year. Soon after that, the rings will reappear, first becoming visible to the largest telescopes, later for everyone else to see. At the same time, further into the future, the rings might cease to exist for good. Astronomers have concluded that Saturn's rings, which mostly consist of ice and rocky dust from smashed asteroids, are younger than we thought. They're losing tons and tons of mass per second all the time, and it's likely to be a few 100 million years at most before they vanish completely. Let's move to the Great Red Spot on Jupiter. This immense raging storm might stop spinning in the next 20 years. The storm in question is larger than our planet. It was first spotted in 1830, but observations from the 1600s mentioned the presence of a giant spot on Jupiter too. If it was the same Great Red Spot, then we can say that the storm has been raging for centuries. The storm's vortex has remained so powerful thanks to Jupiter's 300 to 400 mile-per-hour jet streams. But like any other storm, the Great Red can't keep raging forever. It's been shrinking for a long time. In a decade or two, it's predicted to turn into GRC, the Great Red Circle, and who knows, maybe it will later turn into the GRM, the Great Red Memory. In the late 1800s, the storm was more than 35,000 miles across, 4 times the diameter of Earth. But when Voyager 2 flew past Jupiter in 1979, the storm had already shrunk almost twice its original size. And this shrinking is still happening. In 2017, the GRS spanned the width of a bit more than 10,150 miles, less than 1.3 times the diameter of Earth. Moving on, Pluto's atmosphere is going through a weird transformation. This icy dwarf planet sitting over 3 billion miles away from Earth in the region of the Kuiper Belt drew astronomers' attention in 2018 when it passed in front of a star. With such a powerful source of light illuminating Pluto, researchers managed to examine the dwarf planet and its atmosphere. They came to a shocking conclusion that Pluto's atmosphere is refreezing back onto its surface as the dwarf planet gets colder and colder. Astronomers used several telescopes in different spots in the USA and Mexico to observe Pluto and its thin atmosphere, which is mainly made of nitrogen. This atmosphere is supported by the vapor pressure of ice on the surface of the dwarf planet. For around 25 years, Pluto has been moving further away from the Sun, and its surface temperature has been gradually going down. Pluto is really far from our star at the moment, but at one point it will start getting closer in other regions of its incredibly huge orbit. Besides Jupiter's Great Red Spot, Saturn's rings, and Pluto's atmosphere, we're also losing stars. But stars don't vanish, right? For thousands of years, scientists believed that lights in the sky were fixed and unchanging. Even after they realized those lights were physical objects, just like the Sun, they were still sure that stars went through major changes extremely slowly, on timescales of millions and billions of years. In reality, though, the most massive stars, which can be hundreds of times heavier than the Sun, can go through sudden catastrophic events. For example, once they reach the ends of their lives, they pass away in blinding explosions of supernovae, shining for months on end and visible across hundreds of millions of light years. But there are stars that seem to just wink out of visibility. It should be impossible. And over the past years, a group of researchers tried to figure out whether there's actually a chance of such a phenomenon happening. They started to compare data collected over decades of observations. The project is called VASCO, the Vanishing and Appearing Sources During a Century of Observations. The scientists are interested in all kinds of disappearing objects, but they're hoping to find a star that was steady and present for a long time, and then just vanished without a trace. Even if you point a super powerful telescope there, you'll still see nothing. Our current understanding of space and its laws suggest that stars change very slowly over long periods of time. Dramatic disappearances are supposed to leave noticeable traces behind. Of course, it doesn't mean that all stars should shine steadily. The sky is filled with stars that change in brightness and pulsate. But VASCO is about something very different. They want to find something that goes from a completely steady star to vanishing entirely. Such a phenomenon hasn't been documented yet, and such a discovery might lead to new physics. And now, let's move on to the most disturbing part, the one about the evaporating universe. According to a famous theory proposed by Stephen Hawking, black holes, the densest objects in the universe, evaporate over time. They lose mass in the form of bizarre radiation. But a new study claims that Hawking radiation, or something very similar to it, might not be limited to black holes. It's likely to be everywhere, and it could mean that the universe is slowly but surely evaporating right in front of our eyes. Now, Hawking radiation is something no one has ever observed, but theories and experiments suggest that it can actually exist. Let's see how it works. There's a misconception that black holes are cosmic hoovers, slurping up everything that comes too close with the help of their immense gravitational pull. In reality, though, black holes don't have more gravity than any other body of a similar mass. What they're famous for is their density, incredible amounts of mass packed into a tiny, tiny space. Within a certain proximity to such a dense object, gravitational pull becomes so powerful that it becomes impossible to escape. Not even the speed of light in a vacuum is enough, and that's the fastest known thing in the universe. At the same time, anything massive or dense enough can produce a serious curvature of space-time. In simple words, the immense gravitational field of these objects makes space-time wrap around them. Even though black holes are the most extreme example, space-time also curves around other super-dense objects, like white dwarfs, and neutron stars or galaxy clusters. It means that any super-dense and supermassive object can have some sort of radiation similar to Hawking radiation. And after a very, very long period of time, it could lead to everything in the universe evaporating, following the fate of old supermassive black holes. If it turns out to be true, it will change our understanding not only of Hawking radiation, but also our view of the universe and its and our future.
Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow, didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are 2 ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when 2 magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars in the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing. But have you seen the one with 2 blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth. And when that light goes through the Earth's atmosphere, it creates a big blue blob with a fuzzy outline. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon. When it reflects off the Earth and goes through the atmosphere, the blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 degrees Fahrenheit. This may sound hot at first, but for comparison, our sun is about 27 million degrees Fahrenheit. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the northern hemisphere are familiar with the star named Vega. First, it's brighter than expected. But if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF-14Ls, decided not to obey the rules. It started to fade away like most other stars, but then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once. It kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly, too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, My Camelopardalis. But when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form. They've never really seen it happen. The universe is 13.8 billion years old. And from what we can see, one mysterious star, HD 11402883, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is, at least 13.2 billion years old. While the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with a tail either. It's called Mira. Sometimes it's bright, and other times it's faint, making it a bit of a tricky one to spot in its constellation. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our Sun is a yellow dwarf. And sorry, Sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet Koi 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our Sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the Sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our Sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. Koi 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. Koi 3010.01. This planet is found next to the star Koi 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super-Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. If an asteroid like Apophis hits Earth, we will be destroyed. Massive earthquakes will strike, and tsunamis will flood everything. Apophis is a billion-year-old celestial body that has been in the solar system since its inception. So you might be thinking, well, how likely is it that this giant space stone will collide with our planet in 2029? Well, let's find out, shall we? Apophis is a big, bad asteroid discovered in 2004 by the Kitt Peak National Observatory in Arizona. Since then, it has proudly held the title of one of the most dangerous asteroids ever located. It's around 1,100 feet wide, which is a bit bigger than the Empire State Building and the Eiffel Tower. Because of how scary it is, it was named Apophis, like the Egyptian immortal creature that was considered to bring eternal darkness and destruction to Earth. Oh boy. In 2021, researchers had a once-in-a-lifetime opportunity to study this floating rock when it passed near our planet, and we'll come back to that in a minute. Now, some scientists say that there is a small chance of Apophis hitting the Earth on Friday, April 13, 2029. The Yarkovsky effect is to blame for this, since it can slightly nudge this space rock towards Earth. This effect originates from the uneven emission of thermal photons from a rotating celestial object, resulting in a fascinating force exerted upon it in space. These emitted photons possess momentum and play a pivotal role in shaping the dynamics of the body. The asteroid has two sides, light and dark, just like the Moon. The light side faces the Sun and is warmer than the dark side. But the thing also turns, so the sides constantly change direction and temperature. This change could be detrimental because it slightly pushes Apophis toward Earth. Unfortunately, nobody knows how the Joukowsky effect will influence the asteroid's path. On the other hand, on the asteroid's last flyby of Earth in 2021, astronomers used radar to take accurate measurements of its trajectory and confidently concluded Apophis will safely miss Earth in 2029 by about 20,000 miles and won't bother us again for at least 100 years. Now, generally speaking, every 8,000 years, our planet is hit by a falling star that has similar dimensions to those of Apophis. The last time we were hit by a slightly smaller meteor was in 2013. A new spacecraft developed by NASA called the OSIRIS-REx was launched in 2016 to collect samples from another slightly less terrifying celestial body called Bennu. 4 years later, it finally arrived at the thing, got some samples, quickly said goodbye to Bennu, and started traveling back towards Earth. The samples were safely stored in a capsule dropped in Utah. So far, this has been the most significant sample ever taken from an asteroid. After the delivery, the spacecraft didn't waste any time and started chasing Apophis. Now, OSIRIS-REx has been renamed to OSIRIS-APEX and is currently playing tag with Apophis. With some luck, on the 2nd of April 2029, when the asteroid zips close by Earth, the spacecraft will reach Apophis and land on it. It will stay on Apophis for 18 months, collecting valuable information and taking thousands of pictures. The asteroid will be monitored with the help of powerful telescopes. At some point, Apophis will get too close to the Sun, and then all the monitoring work will be on Osiris's apex back. If you live in Europe, West Asia, or Africa, you're one of those lucky people who will have a once-in-a-lifetime opportunity to see Apophis with the unaided eye. It'll be visible in the sky in these regions in 2029, and those who have telescopes will be able to spot it once again in 2036. OSIRIS-APEX will experience some problems because the asteroid has a thick crust, and the spacecraft won't be able to collect data as easily as it did with Bennu. OSIRIS-APEX has a unique thruster that will blow all the dust from Apophis while landing. This will be a perfect chance to analyze the surface of the asteroid to see what it's made of. The craft will spend 1.5 years mapping the asteroid, trying to detect changes in its shape. All this research will show how the celestial body is likely to move so we can better design plans to protect Earth from such things. In 2025, NASA is also going to launch the mission Apophis Pathfinder, and it will be the first spaceship to ever touch this asteroid. It will land approximately a year after its launch. Also, NASA has proposed sending a swarm of tiny craft into space to help humanity develop effective protective tactics against asteroid strikes. We know that Apophis originated in the primary asteroid belt between Mars and Jupiter. In the past million years, this celestial body has changed its path because of the considerable influence of Jupiter's gravitation. Now it seems like it favors the Sun more, meaning this asteroid will come very close to Earth. That's why it's classified as a near-Earth celestial body. A lot of tests and research have been done to find a way to deal with asteroids. Some solutions include drilling and detonating the space body from inside, or testing new technologies, like attaching rockets to it and trying to steer it away from Earth. We can also hit it with something moving at high speeds to make it change its course. Apophis is an S-type asteroid made of rocks and minerals like iron and nickel, and is shaped like a peanut. It can tell us a lot about the past and possibly the future. Sampling this space object could reveal how life on Earth began and how plants appeared. There are many theories that suggest that water arrived on our planet on an asteroid or a comet. Asteroids are like priceless time capsules. Unlike rocks on Earth, which have undergone thousands of changes, like erosion, most celestial bodies are still intact and much easier to study. When meteors fall on Earth, they get covered in debris that's impossible to clean. That's why studying Apophis while it's still in space is so important. Also, some asteroids are made of precious metals like platinum. Right now, we have a high demand for metals that we use in production, and mining metals on Earth is quite tricky. Just one large meteor might have iron, nickel, gold, and platinum that could last us millions of years. If Apophis has this amount of metals, well, we'd want to break it down and bring it back to Earth. One space rock could be worth quadrillions of dollars, making space mining highly profitable. And still, it would cost us more to get it back to Earth than to dig up these materials here. As technology progresses and new kinds of rockets are developed, this might become possible at some point. So, even though we're safe for the next 100 years from Apophis, you probably still want to see what would happen if something like it did impact. Come on, sure you do. Well, first let me tell you, you'll hear the sound of the collision and know what's happened even if you're miles away. You should leave your house or apartment immediately. Shortly after the impact, massive earthquakes will strike, and many tall buildings will fall. So, staying away from cities might be your best option if you have a choice. But don't escape by car. There will be massive traffic jams, and everyone will panic. Going on foot or by bike is your best option in this scenario. A prime way of transportation will be traveling by plane, so if you've always wanted to get that pilot license, now you've got a good excuse. If you have time, take along extra snacks and water, and an extra pair of socks. It's nice to live by the ocean or the sea, but in this scenario, it's the worst place to be, because giant tsunami waves will hit coastlines after the impact. If you live far away from the impact area, the tsunami might take 30 hours to arrive. You'll have a bit of time to prepare. Now imagine a place where a single day lasts longer than a whole year. On Venus, a day, meaning one full spin on its axis, is as long as 243 Earth days. And what's even weirder, despite the fact that Venus is experiencing a never-ending day, it has a shorter year than Earth. While Earth takes about 365 days to complete one orbit around the Sun, Venus does it in just 225 days. So, somehow, for Venus, a day is more epic than a whole year. Venus is a strange planet in general. It's called Earth's twin because of how alike we are, although it's a bit smaller than Earth. But there are some drastic differences too. For example, it spins in the opposite direction, which means the Sun there rises in the west and sets in the east. And Venus isn't the only one who dances to its own rhythm. Uranus does that too. And finally, Venus is quite crazy in terms of its atmosphere. When you stand on Earth, you don't really feel the weight of the air around you. Well, on Venus, that feeling would be like having an elephant sitting on your shoulders. Venus has 90 times the atmospheric pressure of Earth. The atmosphere there is a thick layer of toxic gases. For example, carbon dioxide that's released by all the volcanoes. It presses down with incredible force. This results in very hot temperatures. No wonder it'll take a long time before we'll be able to stand on this planet. Meanwhile, Mercury, the closest planet to the Sun, has an even more speedy orbit than Venus. It completes a full journey around the Sun in just about 88 Earth days. However, it has a slow spin on its axis, which means that one day on Mercury takes about 176 Earth days, basically half a year. Just like with Venus, a day there takes much longer than a year. Since it's closest to the Sun, no wonder Mercury experiences some super extreme temperature swings. Daytime temperatures can soar up to a scorching 800 degrees Fahrenheit, hot enough to melt lead. But wait for the sunset. At night, it drops to freezing minus 290 degrees Fahrenheit. Ooh! That's because Mercury doesn't have a thick atmosphere like we do, so the heat doesn't distribute across the planet evenly. If one side is in the dark, it'll be super cold, and the other side will be scorching hot, just like if you let a regular big rock lie down under the sun for a while. In fact, it's so cold that there might even be some ice on it. Look at the planet's North Polar region, especially those sunlit yellow spots inside craters. These are indications of water ice. Turns out water is much more common in space than we thought. Mars is often dubbed the Red Planet. It earns this nickname from the abundance of iron oxide, or rust, covering its surface. The iron-rich minerals create a rusty red hue that paints the Martian landscape. But it turns out Mars isn't just red. If you were standing on Mars, you'd witness desert-like butterscotch terrain with caramel and golden glows, some brown, and even a glimpse of a slight greenish hue. Mars also has the biggest mountain in the entire solar system, Olympus Mons, standing at a staggering height of about 13.6 miles tall. It's even taller than Mount Everest. It was formed by the volcanic eruption yielding low-viscosity lava, creating a shield-like structure. Since Mars is covered in sand, it's also famous for its crazy dust storms. But it turns out they're even more insane than we thought. These storms can last for months. While they might present challenges for future human missions, they also contribute to the planet's mesmerizing appearance when observed from afar. And not only storms, but even its own Mars quakes. Also known as seismic tremors, they were first detected by NASA in 2019. Unlike earthquakes that are often triggered by tectonic plate movements, Martian quakes are thought to result from the cooling and contracting of the planet's interior. It's interesting how similar, yet how different the planets are. Saturn's iconic rings might hold a secret link to Earth's ancient past. The rings are composed mainly of ice particles and debris and are estimated to be relatively young in space terms, perhaps just a few 100 million years old. Now, there are some theories that propose that they were born after some catastrophic event. For example, the collision of two large moons or the breakup of a comet. What's interesting is that this timeline coincides with the age of the dinosaurs' demise on Earth. Could there be a connection? Who knows? By the way, while Saturn takes the crown for its rings, it's not the only planet in our solar system sporting them. Jupiter, Uranus, and Neptune all have their own set of rings, although they might not be as visible and cool as Saturn's. However, there's something where Saturn truly stands out: the magnificent hexagon at its North Pole. It's a colossal six-sided figure. Each side of this incredible structure measures around 9,000 miles long, which is 1,200 miles longer than the Earth's diameter. Scientists aren't sure how it was formed or why. They think it might be due to varying wind speeds, or maybe it's shaped by a localized, slow, meandering jet stream. So far, it remains another of Saturn's mysteries. Much like Saturn's hexagon, Jupiter also has its own weird spot. It's called the Great Red Spot. This is a storm that's been raging for at least 350 years and is larger than Earth itself. Despite its name, the spot's coloration has varied over the years, ranging from brick red to pale salmon. Scientists continue to study this enduring storm, unlocking the mysteries of its persistence and ever-changing hues. Meteorologically, the Great Red Spot is a powerhouse. It generates enormous pressure in Jupiter's southern hemisphere. Meanwhile, Jupiter itself is a powerhouse when it comes to magnetic fields. Its magnetic influence is colossal. It extends far beyond the planet itself and creates one of the largest and strongest magnetic fields in our solar system. Because of that, Jupiter is a source of intense radiation and mesmerizing auroras. While Earth's northern lights are breathtaking, Jupiter has something to offer too. The magnetic field interacts with charged particles from Jupiter's moons and the solar wind. This creates visually striking auroras near its poles. But compared to Earth, the scale of these auroras is incredible, like nothing we've seen on our planet. But even having a cool big spot isn't a unique feature in our solar system. A stormy giant Neptune, the eighth and farthest planet from the Sun, also has its great dark spot. Just like Jupiter, it's a massive vortex in Neptune's atmosphere. But unlike its Jupiter counterpart, this spot tends to come and go because of Neptune's dynamic and ever-changing weather patterns. Neptune, together with Uranus, is known as an ice giant. And just like other giants, it boasts some of the most ferocious winds in our solar system. Its supersonic winds can get faster than 2,200 miles per hour. What a drama queen! But this explains its thick cloud formations. By the way, if you ever dreamed of a planet raining diamonds, you might want to visit this planet. Deep within Neptune's atmosphere, where pressures are extreme, scientists theorize that carbon atoms are compressed and form diamonds. And then, these diamonds might be raining down. What a unique touch to stormy weather. Neptune's moons got from their parent with the weird weather. For example, its largest moon, Triton, has a touch of cryovolcanism. Instead of spewing molten rock like Earth's volcanoes, Triton's cryovolcanoes erupt with a mix of water, ammonia, and nitrogen. Picture it as icy geysers shooting material into space. Seems like in our solar system alone, each planet has its own quirks and interesting qualities. Let's hope that we discover some more interesting things in outer space in the future. So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the 5th largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, this next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
when astronomers started a project that was organized to create a detailed 3D map of our galaxy, they didn't expect to find anything surprising. But that's exactly what happened. Earlier in that year, Harvard scientist Dr. Anna Bonacca noticed a weird disturbance in our galaxy's stellar streams. A stellar stream is a line of stars that are moving together through galaxies. The stellar stream we're talking about is called GD1, and it's stretched in an impressive line across our sky. This stream used to be a cohesive line stretched by the gravity of our galaxy. One day, Dr. Bonacca noticed a gap in it, and this gap had a strange, ragged edge. In fact, it looked like something terrifyingly huge recently plunged through the stellar stream. The sheer force of this object's gravity was so great that it managed to drag stars in its wake. The most shocking thing was that the telescopes simply failed to find the source of the damage. But then, what could this unseen bullet be? One theory suggests that the intruder is a stray star. But, according to Dr. Bonacca, the hole is way bigger than any existing star. It'd have to be 1,000,000 times more massive than our sun. Okay, so what if the hole in the Milky Way was torn by a supermassive black hole, like the one that dwells in the center of our galaxy? If these two black holes got too close, they wouldn't be able to escape each other's gravity. A collision might be inevitable. Then the stronger of the two holes would consume the weaker one, and one huge, super mighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right, one of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonacca still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, it's hard to predict where it would have ended up if it were a luminous object. The intruder could have been moving at an incredibly high speed and wouldn't have to be very massive to tear a hole in the stellar stream. Or it could have been moving more slowly, but be very heavy. But the astronomers don't know which option it was. That's why it's next to impossible to predict where it ended up.
It was the year 2017 when astronomers spotted a bright star hurtling out of the Milky Way. It was moving incredibly fast at a speed of 2 million miles per hour. That's almost 4 times as fast as the Sun orbits around the center of our home Milky Way galaxy. It takes our star more than 225 million years to complete one journey. Anyway, back to our star, the Wanderer. The main issue with it was that it was moving against the direction in which most stars travel around the center of our galaxy. Even more bizarre, it consisted of totally different star stuff. Astronomers managed to identify its composition. The star was made up of heavy metallic atoms. At the same time, most of the other stars consist of way lighter elements. The wandering star got the name LP-40-365. It was moving so fast that it literally dashed out of our galaxy. This made scientists believe that the space traveler was pushed out of its place by some kind of cosmic disaster, like a supernova. A supernova is the largest explosion that can take place in space, an explosion of a star. It happens after irreversible changes start in the core of a star. Supernovas can occur in 2 ways, in binary star systems and when there's a single star. Binary stars are two stars orbiting around the same center. At some moment, one of the stars, a very dense white dwarf, starts stealing matter from its companion. After some time, this thief accumulates too much matter, which causes it to explode into a supernova. Or it can be a single star nearing the end of its life. It's running out of its fuel. More and more mass is flowing into the core of the star. In the end, the core becomes so heavy that it fails to withstand its own gravity. After the core collapses, a tremendous amount of energy is released in a supernova. But astronomers still can't figure out how a supernova could send LP-40-365 flying. There are more questions than answers. Was it a companion star that got flung out by a shockwave created by a supernova? Or was it a piece of the exploded star? A new study based on the collected data has shown that the star, which is a white dwarf, keeps slowly rotating around its axis. Astronomers are almost sure it means LP-40-365 is indeed just a chunk of space debris, and not a full-fledged star. This wandering piece somehow managed to survive one of the fiercest space events. But after making such a conclusion, scientists realize something amazing. LP-40-365's unusual features could appear after the star witnessed a supernova. Even though this event happened lightning fast, the entire makeup of the star got changed. Most stars consist mainly of helium and hydrogen, but LP-40-365 is different. It contains such heavy elements as magnesium, oxygen, and neon. It must have been the supernova that added these atoms to the star's composition. By the way, astronomers consider all elements that are heavier than helium to be metals. This means that after witnessing the supernova, LP-40-365 became metallic. Right now, the star doesn't have its own planets, but NASA's Transiting Exoplanet Survey satellite, which is on the lookout for distant planets passing in front of their host stars and dimming them, has noticed a curious thing. LP-40-365 brightens and then dims again every 8.9 hours. It might mean that the star pulsates, but usually, stellar pulsations are much less regular. A more plausible explanation is that the star's surface is uneven, and as it spins, sunspots are brought into and out of view. And it's great news, because after astronomers figure out how fast the star rotates, they can understand what happened to it around 5 million years ago during the supernova. Bright blue exoplanet HD 189733b looks peaceful and eerily familiar. Doesn't it resemble Earth? But this appearance conceals the planet's terrifying nature. There, the winds blow at 5,400 miles per hour. It's 7 times the speed of sound. But that's not the worst. It rains glass, sideways, in this scorching hot world. Neutron stars are ultra-dense collapsed cores of giant stars. They emit X-rays or radio waves. But in 2018, astronomers discovered a weird stream of infrared light. It seemed to be coming from a neutron star 800 light-years away from our planet. The most plausible theory is that this signal was probably produced by a disk of dust surrounding the star. But there isn't enough evidence to confirm this idea. Mercury is the fastest planet in the solar system. It zips around the sun at a breakneck speed of more than 100,000 miles per hour. That's around 40,000 miles per hour faster than our home planet. It's one of the reasons why a year on Mercury equals 88 days on Earth. Mercury is the planet that orbits the closest to the sun. That's why if you were standing on its surface at its closest approach to our star, the sun would look more than 3 times as large as it does on Earth. The Black Widow pulsar is a rotating neutron star that is munching on its partner, which is a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes the companion star to dwindle. There's a stellar nursery in the constellation Centaurus, and even though this place is called a nursery, it's anything but peaceful or safe. It's made up of hydrogen and newborn stars and is located in a nebula around 6,500 light-years away from Earth. A nebula is a giant cloud of gas and dust floating in space. The intense energy baby stars emit makes hydrogen clouds glow ominous red. This energy is so powerful, it's eating away dark clouds of dust. Astronomers can see them disappear like lumps of butter on a hot frying pan. Faraway Neptune-sized exoplanet Gliese 436b is a paradox. It's made of scorching hot ice, and this ice is burning. The planet completes one full orbit around the red dwarf Gliese 436 in just 2 days. It means the exoplanet travels very close to its parent star. That might be the reason why the planet's temperatures rarely drop below 800 degrees Fahrenheit. But the strangest thing? The planet hosts huge volumes of water ice known as Ice X. And this ice remains solid despite such incredibly high temperatures. Jupiter is the largest planet in the solar system. It's 318 times as massive as Earth. It's also 2.5 times as massive as all other planets of the solar system combined. But here's a paradox. If this gas giant got even more massive, it actually becomes smaller. The added mass would make the planet denser, and this would cause it to start pulling in on itself. Astronomers claim that Jupiter can eventually end up being 4 times as massive as it is now. But at the same time, its size won't change. DGSAT-1 galaxy is as big as the Milky Way, but it's nearly invisible because its stars are spread out incredibly thin. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind. Those are usually found in clusters. It can mean that DGSAT-1 was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Saturn's moon, Hyperion, is one of the most bizarre-looking moons in the solar system. But the appearance isn't the strangest thing about this space body. The pumice stone-like rock is pockmarked with countless craters, and it's also charged with static electricity, which is flowing out into space. About 4,000 light-years away from Earth, there's a planet that seems to be one enormous diamond. The planet is denser than any other discovered so far and consists mostly of carbon. It's so dense that astronomers think this carbon might be crystalline. It means that at least some part of the planet is diamond. Ceres is the most massive space body in the asteroid belt between Jupiter and Mars. It totals almost a third of the entire mass of the whole belt. But at the same time, Ceres is the tiniest of the dwarf planets out there. It's also the only dwarf planet that dwells in the asteroid belt, and also the only one that is located in the inner solar system. Astronomers sometimes call Jupiter a failed star. The gas giant indeed contains a lot of helium and hydrogen. But its mass isn't enough to start a fusion reaction in its core. And that's exactly how stars produce energy. They fuse the atoms of hydrogen together under extreme pressure and heat and create helium. In the process, they also release light and heat. Jupiter could start a nuclear reaction and become a star only if it was 70 times its current mass. Space is completely, eerily silent. That's because in the vacuum of space, there's no atmosphere, and the sound waves need some medium to travel through. That's why worlds with atmospheres like Earth are full of noise. Unlike their massive siblings, hypothetical mini black holes could be really tiny, not bigger than an atom. Even so, just one minuscule thing would have enough mass of 1,000 sedans. One theory claims that tons of micro-black holes could be created right after the Big Bang. Some scientists even go so far as to say that a couple of mini black holes pass through our planet every day. Every hour, the sun sends more energy to Earth than our planet uses in a year. Even though people are now using much more solar energy than a decade ago, it's still a mere 0.7% of the world's annual electricity usage. There might be moons orbiting other moons, but astronomers haven't agreed on this theory yet. Planets orbit stars, moons orbit planets. But why can't there be moons, also known as submoons, moonettes, and moons? Researchers claim that moons could exist, but the host moon has to be massive enough and the moon small enough. There must also be a large distance between these moons and the host planet. Jupiter is the most massive planet in the solar system. This means its gravity is also the most intense. It's 2.5 times as great as what we have on our home planet. Once, the gas giant's gravity even tore apart a large comet called Comet Shoemaker-Levy 9. Then the planet eagerly swallowed the chunks of the former comet. If you were standing at the equator on Mars, the temperature at your feet would feel like that of a warm spring day, but your head would be literally freezing. Lost in space and drifting through galaxies, rogue planets were once flung away from their parent stars, but one of them, floating 200 light-years away from Earth, is different from the rest. It's a planet-sized object with a magnetic field 200 times stronger than that of Jupiter. This field is so powerful that it generates never-ending flashing auroras in the planet's atmosphere. Europa is one of Jupiter's largest moons, even though it's smaller than Earth's moon. But the cool thing about this satellite of the gas giant is that it's covered with ice. And some of this ice is smooth, which means you could skate there. And a 3-foot axle jump you can perform on our planet would take you 22 feet into the air. At the same time, the landing speed on Europa would be the same as it is on Earth. Haumea, a dwarf planet orbiting the Kuiper Belt, has a bizarre elongated shape and 2 moons. The day on this planet lasts 4 hours, making it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile-wide ring circling it. Astronomers haven't managed to figure out how or why it appeared around the dwarf planet. 11 Earths could fit across the equator of Jupiter, and if our planet was the size of a grape, the gas giant would be as large as a basketball. 9 spacecraft have already visited Jupiter. 7 of them just flew by, and 2 orbited the huge planet. The most recent of them, Juno, arrived at Jupiter in 2016. The craters of the moon's south pole are likely to be the frostiest place in the whole solar system. The crater's floors are always in the shadow. That's why the temperature never rises above 397 degrees Fahrenheit, even during the day. If you decided to fly a plane to Pluto, your journey would take around 800 years. You'll find the highest mountain in the solar system on an asteroid called Vesta. Its peak rises 14 miles above the base of the mountain. This makes Rise Sylvia, that's what the mountain is called, almost 3 times taller than Everest. Saturn's rings weren't discovered all at once. It happened gradually. That's why they were named alphabetically in the order scientists found them. Now they go like this: D, C, B, A, F, G, and E. A day on Venus is around 243 Earth days long. But the bad news is that you'd have to wait for a weekend for 3 years. All because a day on Venus is longer than its year. A solar phenomenon called terminator events is taking place at the Sun's equator. Disastrous magnetic field collisions seem to cause ginormous twin tsunamis of plasma. These tsunamis tear across the star's surface, moving at a speed of 1,000 feet per second. They can last for weeks at a time and happen almost every decade. The winds on Neptune are the fastest in our solar system. Most of them can reach the speed of 1,600 miles per hour. Almost any of these enormous storms could easily swallow our entire planet. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because a ring of dust and debris circling it makes it look like a giant eye staring into your soul. The intimidating star is more than twice the mass of our Sun and is 25 light-years away from Earth, which isn't that far away considering distances in space. Mars has 2 moons, Phobos and Deimos. In the next 30 to 50 million years, the planet's gravitational forces will tear Phobos apart. It'll probably result in the formation of a ring around Mars. An asteroid the size of a car enters the atmosphere of our planet every year. Such an intruder could wipe out a small town off the face of the Earth. Dust and smoke would rise into the atmosphere, preventing sunlight from reaching the surface of the planet. It would cause the temperatures all over the world to drop and the climate would change. Luckily, such asteroids burn in the atmosphere before they even come close to the surface. The radio signal produced by a spacecraft when it contacts Earth is less powerful than a light bulb in your fridge. By the time this signal reaches our planet, its power is only 1/billionth of a watt. No wonder that antennas gathering these super weak signals are huge. The Deep Space Network that detects signals from spacecraft has dish antennas that measure up to 230 feet across. That's more than the width of a soccer field. In 1999, NASA lost a Mars orbiter because one engineering team was using the metric system, and another was doing calculations with the help of the imperial system. Nebulas are giant clouds of gas and dust. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, a nebula's mass becomes so great that it collapses under its own gravity and forms a new star. Around 4,000 light-years away, in the constellation of Scorpion, there is the Butterfly Nebula. Its wingspan is greater than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an insane 450,000 degrees Fahrenheit. This means it was formed from another huge star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. If you decided to lump together all the known asteroids in the solar system, their total mass wouldn't exceed even 10% of the mass of our moon. A cloud of water vapor is floating in space. It surrounds a supermassive black hole 12 billion light-years away from Earth. The cloud contains 140 trillion times the entire volume of water on our planet. Astronomers think this water cloud appeared just 1.6 billion years later than the universe itself. The densest objects in space are neutron stars. They're the size of a small city, yet their mass is about 1.4 times the mass of our Sun. A single teaspoon of neutron star material would weigh 1 billion tons. And a neutron star's gravity is 2 billion times stronger than the gravity of our planet. In 1993, the Galileo probe was traveling past a miniature asteroid. It was no more than 20 miles across, and still, the tiny thing had a 1-mile-wide moon. Astronomers have discovered tons of moons orbiting minor planets in the solar system since then. We live inside the Sun. The star's atmosphere stretches way beyond its visible surface, and our planet is well within its reach. That's how the gust of the solar wind creates such a breathtaking phenomenon as the northern and southern lights.
When a team of astronomers embarked on an ambitious project to craft a comprehensive 3D depiction of our galaxy, they anticipated standard findings. Yet, they stumbled upon something completely unexpected. Dr. Anna Banaka, a distinguished scientist from Harvard, detected an unusual interference in the stellar streams of our galaxy. These stellar streams are essentially pathways of stars that traverse galaxies in unison. The specific stream in focus, named GD1, spans a remarkable distance across our celestial canvas. Historically, this stream maintained a consistent line, molded by the galaxy's gravitational pull. However, Dr. Banaka observed an anomaly, a gap with an irregular outline. It appeared as though a massive entity had recently burst through GD1, its gravitational prowess pulling stars along its path. Intriguingly, telescopes couldn't pinpoint what caused this disruption. The burning question then was, what could this invisible force possibly be? I hope this unknowable force doesn't stop you from clicking the subscribe button, giving it a like, and hitting the bell. Your support is very important. Thank you. There's a hypothesis that an unfamiliar star could be the culprit. However, Dr. Banaka believes that the size of this disturbance is much larger than any known star. It would need to be a staggering 1,000,000 times the mass of our Sun. But let's consider another possibility. What if a gargantuan black hole, akin to the one at our galaxy's core, caused this disruption in the Milky Way? If two such black holes neared each other, they might get trapped in their mutual gravitational pull, leading to a potential catastrophic collision. Then the stronger of the two holes would consume the weaker one, and one huge supermighty black hole would appear. But people have yet to witness a collision of black holes. Plus, scientists can't predict the consequences of such a merge, even though they've simulated it on powerful computers. The only obvious fact is that it would produce incredible amounts of energy. Huge ripples would travel through the entire universe, bound to hit our planet eventually. Then again, two black holes in one galaxy might refuse to merge. Imagine this. A supermassive black hole hundreds of millions of times the mass of the Sun is spinning in the center of the Milky Way at a phenomenal speed. Another spinning black hole approaches ours. What do you think will happen? Right. One of the holes, most likely the intruder, will get kicked out and sent hurtling away like a frisbee flying through space. And who can guarantee that it wouldn't head toward the Earth? Luckily for us, there aren't any supermassive black holes in the vicinity, so this theory fails to explain the mysterious bullet hole phenomenon. Dr. Bonica still doesn't rule out the possibility that the intruder is some kind of luminous, star-like object. After tearing a hole in the Milky Way, it could be hiding somewhere in the galaxy. But again, it seems highly unlikely because of the object's huge size. I mean, we're talking 30 to 65 light-years across. In any case, predicting the location of this mysterious intruder is as challenging as guessing where your missing sock disappears to after laundry day. Speaking of things disappearing, don't let this channel vanish from your feed. Hit that subscribe button. The intruder could have been blazing fast, requiring minimal mass to cause such a disturbance in the stellar stream, or it could have been a slower, massive behemoth. Astronomers are still scratching their heads, which just goes to show that some mysteries are harder to unravel than others.
You switch on the light as soon as you enter a room. You never even stop to think about counting how long it takes for the bulb to light up. You couldn't. It's as if it's instant. Well, technically you could if you were fast enough. Good luck clicking that stopwatch in time when you're measuring over 670 million miles per hour. That's 180,000 miles per second. Almost the distance from the Earth to the Moon in the snap of a finger. Oops, wrong sound effect. Can you give me a finger snap? Yeah, that's it. In the snap of a finger. And the Moon's further away than you probably think. If all the planets in the entire solar system were lined up in one epic conga line, they'd fit between the Earth and its satellite. And that's including poor outcasted Pluto. Okay, light is fast. Moving on. It's a beautiful sunny day, perfect for a jog. And like any other day you go for a run, you stop and think, hey, I wonder what the speed of sound is. Don't you? Well, definitely not nearly as fast as light. Need proof? Check for yourself next time it storms in your area. You'll see lightning flash before hearing the crack of thunder. The light from that bolt rushed to you, zoomed into your eyeballs, and up into your brain for you to understand, oh, lightning. All the while, the sound wave from the thunder is still on its merry way to your ear. It'll get there, just give it time. By the way, thunder isn't the sound of storm clouds crashing together. It comes from that very same lightning bolt. It races toward the ground and rips a path through the air as it does. The air politely moves aside to make way for the lightning, and in the instant the lightning's gone, boom! The air comes back together and makes the sound we call thunder. Oh, and here's a fun fact. Sound travels faster underwater than in the air. A little over 4 times faster to be exact. So if you were to go for a swim with your friend and shout something bizarre underwater, they'd hear it a bit sooner than if you did the same thing outside of the pool. Uh-oh, everybody else heard it too. Oops. Sound also travels over longer distances underwater. It's why humpback whale calls can be heard for thousands and thousands of miles. But in a controlled environment where the air is dry and we have a constant temperature of 68 degrees Fahrenheit, the speed of sound is about 760 miles per hour. Now, that's a more realistic number, one that people can even reach. The famous Bell X-1 aircraft was the first to break the sound barrier on October 14, 1947. Test pilot Chuck Yeager was in the cockpit of the rocket plane. Imagine hearing that sonic boom for the first time ever in history. Bravo, Captain! Humans can race with sound, but light is a whole different challenge. For one, measuring it in the first place is no easy task. The official speed of light has changed several times throughout history, even going back to the 1600s. After centuries of debate and experiments with different results, the scientific community finally settled the matter in 1983. Maybe. To measure the speed of anything, you'll need to know two things: the distance between point A and B, and the time it takes for an object to travel between those points. With distance divided by time, you'll have yourself the speed of light. But with every experiment done to measure light speed, there's always been an extra cog in the wheel that everyone overlooked, or rather brushed aside. When doing an experiment using light beams and mirrors, we've always included the light beam's trip from A to B and back to A. With equal speed and equal distance, we have ourselves a controlled experiment and conclude an official speed number for the books. Case closed. Let's celebrate! Not so fast. A certain someone in 1905 had something to say about this, and that someone put a theory out there that light can travel different speeds going forward and back. Still can't wrap your head around it? Well, let's take this example. You had a long day. You pulled an all-nighter at work and can't wait to sink into your comfy warm bed. You get on a bus and head home. The night's clear and there's zero traffic on the road. Before the wheels on the bus can even go round and round, you immediately conk out in the back seat. But right before that, you checked the clock and saw it's exactly 10 p.m. What? After a big bump on the road jolts you awake, you become aware of your surroundings. But you suddenly find yourself in the exact same spot as the moment before you fell asleep. That was a quick nap. But then you look at your watch and it's now 11 p.m. You fell asleep in the bus and missed your stop. You'll have to repeat the exact same route all over again. Bummer. What can you determine from this? Since the whole ordeal took you an hour, you can assume it took exactly 30 minutes from the bus stop to reach your house and another half hour from your house back to the bus stop. Sounds logical, right? In our physical bodies, such a conclusion makes perfect sense. But it was Albert Einstein who challenged this idea. With his reasoning, the trip could have taken 59 minutes to get home instead of 30 and 1 minute back to the bus stop. Or even vice versa. Since you were fast asleep, there's no way you can know. And this idea is what's keeping scientists and physicists up all night throughout the decades. When you get into light speed in space, then the mind-blowing stuff starts happening. It takes approximately 8 minutes for light to reach Earth from the Sun. So, light is super slow in space? Not really. Now we're talking unimaginable distances. It takes 8 minutes for our sun's light to travel over 90 million miles to our planet. That's something to think about when going to the beach. The sunlight that made your tan lines traveled so far across our solar system to reach your skin. Ah, how thoughtful. And you can get sunburnt even on a cloudy day. That's how powerful our star is. Now, imagine yourself living on Pluto. I know, its planet membership got revoked in '06. But hey, call me old school. Our former furthest planet from the Sun is so far away, it takes 5.5 hours for sunlight to get there. No wonder it's always cold. The first planet in line is Mercury. The Sun's rays reach it in a mere 3 minutes. Hey, that's probably enough time to listen to your favorite song. By the time the song ends, you, the Mercurian version of you, will be basking in the Sun's glory. It'll be impossible to listen to that track in space since sound can't even travel out there. You know, no one can hear you scream. Oops, there she is again. Music is just vibrating air, and without any air in space, sound can't travel. That explains why it's so eerily quiet out there. Okay, can somebody take the scream girl down the hall? And while we're up in space, let's pay our neighbor a little friendly visit. Alpha Centauri is the closest star system to our own. And what fun, the trip is just 4 light-years away. That's 25 trillion miles and 137,000 years on the road. Yeah, don't forget to pack a big lunch. To put all that in perspective, it would take around 5,000 generations in a super shuttle traveling through empty vast space to complete the journey. And we won't be able to come close to the star. Oh, and that's just one way. Okay, I think I'd rather come back to Earth now. Whew, that's better. Now, the longing question: how can we measure the speed of light without that little dilemma about the return trip? Oh, I got it. Why don't we just measure the speed with a super high-tech camera and map it out frame by frame until we're able to write down its speed? Well, nothing's as easy as it seems in the world of physics. Because when filming the light through a lens, we're not seeing the light itself, but rather a reflection of it. We just circled back to square one. Okay, scratch that plan. Then how can we prove light is going the same speed to its destination as its reflection is back to point A? Does the one-way speed have a defined value that's not a constant? Well, this is the ultimate question among scientists, and so far, there's just no way of truly measuring it. Unlike the speed of sound, which is more conceivable, the speed of light might just be light years ahead of us. Yes, just more fun light facts brought to you by The Bright Side. See the tie-in? Okay, never mind. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry?
The speed of light is the fastest thing in our universe. It travels across space, passing through Mercury and Venus to reach us, and it's slowing down. No need to panic though. The sun is getting weaker, but we won't see the effects of it for another billion years. In the vacuum of space, the speed of light is around 186,280 miles per second. Any slower than that, and humans would see the changes firsthand. There would be some awesome effects, like colors changing and the brightness of objects fading. We'd also notice some differences in everyday objects, their length and shape. Scientists created a simulation to see what would happen if the speed of light was slower. In a vacuum, the speed of light can't change, but if light passes through different materials and objects, it alters the way we perceive things. Light acts as a wave and a particle, meaning that it's a wavelength. The color and frequency are determined by the distance from crest to crest in the wave. It behaves similar to sound with the Doppler effect. Imagine you're standing in the middle of a busy highway and a honking car speeds through. Wow, that was loud. You can hear that whoosh-like sound of the horn because the moving object produces the sound while you're stationary. The frequency and pitch seem to change, but it's just the sound reaching your ear faster than it would if you and the car were both stationary. Light behaves similarly. The wavelengths change if the speed changes. Moving toward a light source and making the wavelength shorter will shift the color to a blue and violet hue. Moving away from the light source, and you'll get something more reddish. So if the speed of light slowed down to walking speed, we'd notice the colors changing when we approach an illuminated object. At the same time, the color would change around us and behind us. If you walk sideways, the colors you're walking toward would become bluer, and everything in the distance would become red. This information is useful to astronomers who are studying objects in space. If they're blue shifted, that means the object is moving towards us. And if it's red shifted, then it's going in the opposite direction. In fact, everything in the universe is red shifted, proving that the universe is expanding and getting further away from us. The slower it gets, the brighter it becomes. That's because the photons become more present for us to see. At this rate, we can see invisible light and increased intensity. You won't notice that effect much if you're standing still, but because of the Doppler effect, moving towards an object will have different colors and different light intensities. Another phenomenon we'd experience is time dilation. It's when you move at a similar speed as light and time decreases relative to someone who isn't. Space and time are relative. So if you're sitting at your desk wasting hours away, yeah, sounds familiar, doesn't it? All your movement will go through time and not through space. You're stationary, but you're still technically moving forward in time, slowly aging. The faster you move through space, the slower your movement through time will be. If you move at the same speed as light, then all your movement will be through space and not through time. To notice that, you'd need another person to watch you. You're not in a time machine. You're both on Earth, experiencing the same time flow. To you, experiencing this firsthand makes it feel like you're going faster, because you're getting a lot more movement in space in a given time. The closer you get to the speed of light, the smaller you become. Well, not really, but it depends on who's watching. If you're the one traveling at such a speed, an object nearby will seem small, just as someone who's watching you travel at the speed of light will think that you're smaller than you actually are. The simulation that the MIT scientists conducted showed that if the speed of light drops, everything will become stretched out like a pancake. If you see mountains in the distance and then run at the speed of light, they will appear further away. Objects will become distorted, and it will feel like you're getting to a certain place faster because time has slowed down for you. If you're standing completely still and someone standing on your left-hand side throws a cube-shaped object over to your right-hand side, then naturally, you'll see one side of it unless it flips around. But in this new reality, you'll get to see the front side wrapping around the visible side you're seeing. If you're moving at the same speed as light in an infinite space, everything will be stretched out as you reach infinite speeds. In a world where people can walk at the same speed as light, we'll perceive nothing as normal. We'll have to get used to the way we see objects. Every movement we make will result in drastic shifts of colors. Even turning your head to look at something will feel weird. Let's say you're in a supermarket buying groceries, and you walk from aisle to aisle. The milk at the end of the counter will look like it's really close to you. But when you approach it, you'll start to feel like it's getting further away from you. The milk will also look a bit red. As soon as you get closer to it, it will shift to blue. If someone is passing through with a shopping cart, you'll see it as a sort of 3D model of a shopping cart. The color will shift as it gets further away from you. It will appear far away, but it's right in front of you. In fact, we don't really know the actual speed of light. Physicists gave it roughly 186,280 miles per second, but that constant is just for them to calculate other scientific stuff so we can understand it better. The problem is that we can only measure light with light beams and mirrors. But it's not like all we have to do is point a light beam at a mirror and measure its original path and its reflected path. Einstein's theory of relativity states that the original path of light moving from the source to the mirror may not be the same speed as the reflected light from the mirror back to the source. Hypothetically, if it takes light 10 seconds to travel from the source to the mirror and then back to the source, then we can conclude that each trip takes 5 seconds. But Einstein's theory is that it could take 9 seconds for light to travel from the source to the mirror and only 1 second from the mirror back to the source. Or vice versa. Or maybe completely different numbers altogether. That's why it's so difficult to measure light. A breakthrough came out for scientists when they managed to slow down the speed of light to 0 without losing its brightness. They did this by using ultra-cold atom clouds made with photonic crystals. These crystals are materials punctured with billions of tiny holes where light can refract. But what if we lived in a world where light stopped halfway? You'd wake up one morning and feel like it's twilight. You'd open the curtains and see that many car lights are on, but aren't so bright. You turn on the lights in your room, but feel like the bulb is tapping out. You replace it with another one, but it doesn't do the trick. You turn on the lights everywhere in your house, but it's all just giving weak light. You're confused and try to check if there's a problem with the electricity in your house, but it seems to be working well. You check on your neighbors, and they also have the same problems. Even experts in the field can't understand what's going on. Hours pass, and it's all the same. All the light in the world seems to have frozen halfway. Your phone is low on brightness, even though you bumped it up to maximum. Everything is getting darker. You learn from the news that it's a global problem. Light is slowly diminishing, and soon there won't be any of it in the world. You decide to wait it out while everyone else is panicking.